Hello, let's continue our Sudoku adventure with Slanted Rooms by Strosahl. This continues our indexing theme week, so there's going to be some kind of counting involved, basically. So let's go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these diagonal numbered room clues. So you'll notice we have a diagonal arrow and then a clue next to it, a digit next to it. So clues outside the grid indicate the digit, which has to be placed in the nth cell in the direction of the arrow. And n is the digit placed in the first cell. So if this was a 3, then we would count 1, 2, 3. It's the third cell, and we would put a 4 there because the clue is a 4. If this was a 2, we'd put a 4 here. If this was a 4, we would put a 4 here. But there's an issue with this, which is that we have a note. The clued digit may appear elsewhere along the indicated diagonals as well, but the n will point at the first such instance. This is the second instance, so this n shouldn't have been a 4. So anyway, that example is actually breaking that note that we have at the bottom. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, how shall we get started on this? There's a couple observations we can make, which I kind of hinted at in my rules description, which is that a 4 here doesn't actually work because the 4 would then be the first, so n should be 1, which means we need a 1 here. So they're kind of conflicting. We need both a 1 and a 4 there. It doesn't work. You also can't put a 1 on a numbered room clue that isn't a 1 itself. Like this would work. The first digit is a 1. That actually succeeds. But here, the first digit isn't a 4. And we can't put a 4 there because there's a 1 there. So we can't put 1s or itself in any of these cells, and you can put yourself in these, but not in both because they're in the same column. So am I above? I don't think I'm above doing this. So I'm going to type 1 through 6. We're going to remove 1 from all of these. And then here, these aren't 4, that's not 5, that's not 3, and that's not 6. Now also, we can't have n be bigger than how many we point to. So 1, 2, 3, 4, 5, so this can't be bigger than 5, so not a 6. 1, 2, 3, 4, this can't be bigger than 4, so not 5 or 6. 1, 2, 3, 4, 4, 5, this isn't a 6. 1, 2, 3, 4, this isn't 5 or 6. And 1, 2, 3, 4, 5, this is not a 5. All right. Now, that means that there's a 4 here or here. There's also a 4 here, here, or here. How many does this point at? 1, 2, 3, 4. So this is just 1, 2, 3, 4. This I think this can be up to 6. So we don't know what's going on with this one. 5 is here, here, or here. 6 is here, here, or here. Four is here, or here. So we know because 4 is in one of these two, let me highlight that. 4 is definitely in one of these two greens. And so notice that these cells and these cells see both greens. So they cannot be the 4. Not 4 isn't something I can really mark, and I could do 1 through 6 and remove the 4, but that's very pencil heavy. So let's hold off on that. But 4 isn't one of those two. That's an observation we can make. Oh, okay. So actually, because 4 can't be here, this can't be a 3, right? If I tried to put a 4 here, I wouldn't be able to put a 4 in either of the greens, and then this would be wrong. So this is not a 3. 2 would actually not work either, because if I was a 2, I'd have a 4 here. This would be a 2, and now this would want to be a 2 as well. So that doesn't work. And because we know that it always points at the first instance, which is a very important deduction. And so this is actually 5 and 3. And that puts a 4 here. And then the 3, sorry, yeah, puts a 4 here, and then the 5 is all the way at the end here. So that's not 4, that's not 3, that's not 4. So 6 is here or here. 5 is here or here. Huh. 3 is here or here. Oh, 3 can't be here. There's a 3 in the row. So this is a 4. That puts a 3 here. This is a 2, which puts a 5 there. This is not a 4. So 1 is in one of these two. 6 is one of these two. Maybe I can start doing some Sudoku here. So 3 is in one of these two. 5 is in one of these two. 4 is in one of these. Ah, sorry, 4 is placed. That's even better. 4 looks down, 4 looks in. So that's 4 and that's 5. Um, 4, 2. I don't know if I want to start penciling yet, but hold on. What else can I do? 4 is actually placed in here as well. Can I finish the 4s? I should be able to. Yeah, that's our last 4. Okay. Uh, where's our first 1 along here? I wonder. So it's not here, because the 1's over here. That's all I know. 6 is one of these two. So this can't be 6. So it's not 1. It's not. Okay. So it could be 2, 3. That's it, right? Because it's not 1. It's not 4, 5. And it's not 6 because 6 is in one of these two. Huh. Oh, yeah. No, I did that. Sorry. This is just a pair. I'm going to pencil this. A 1, 6 pair. I guess I have to start penciling. This is 1, 2, 6. We know 5's one of these two. This is 1, 5, 6. What else is it like? 1, 2, 6 here. Okay, so something else we can say, for example, is that these two are not 3, or they would be closer to this 4. So, for example, normally this would be from 1, 2, 3, 6, but it can't be a 3. So it's down to 1, 2, 6 only. This can't be a 3 either, so it's also down to, oh, sorry, it already couldn't have been a 3. So that's not helpful. Do we have more like that? So this 4, this is the 5th 4. We've got that done. Same with this one. Okay. So what am I missing about this? 1, 2, 3, 6. I don't see more Sudoku to do. 5's one of these two. Oh, 5 is placed in here. There's more Sudoku. That's a 5. That's not a 5. Places the 5 here. Places the 5 here. And 5's are done now. So 4s and 5s are done. 1, 2, 3, 6. Ooh. It would be tough for this to be a 6, because we couldn't have any more 1s along here. It's not... It's possible. I guess is what I'm saying. That'll be pretty interesting, actually. What's going on here? 1, 2, 3, 6. Don't really want to pencil more of that if I don't have to. Let's see. 1, 2, 3, 6. So we know 6 is down here, which means 6 is up here. So this is not a 6. This is 1, 2. This is 1, 3 only. 1, 3, 6 for the column. Am I missing something about this? Okay. I mean, so the thing is, if this is a 1, we're allowed to have any of these be 1s. If this is a 6, it does force this to be a 3. This to be 2, 6. But I wonder if doing 6 and 3 is a problem for some reason. Oh, actually. Oh, that's really interesting. I don't know if there's an easier way to approach this, but look at these 1, 6 pairs. This is really neat. So these two are the same digit as each other. So if they're a 1, then this has to be a 3, because it can't be a 1. There'd be a 1 in the column already. So if green is 1, then that's a 3, right? But if green is 6, then this has to be the first 1 in the diagonal, meaning that can't be 1 anyway. And so no matter whether this is 1 or 6, this cannot be a 3. So we can place that 3 there, and then place the 3 there, and that gives us the 6 here, which means that cannot be a 6, because again, it can't be closer. So we can clear these out. This is purple. if we want to continue. Down here we have 1, 2, 6. Oops, not colors. There we go. 1, 2, 6. And so this has to be the 3 for the column. This is down to 1, 2, 6. Now, all right, this can't be 6. I already said that. Oh, 6 in this row goes here. 1, 2 pairs. This is our 3. This is 1, 2. We still haven't resolved this guy. I'm not sure this coloring is at all helpful. 1, 2 pairs, maybe? I mean, might as well color it and see what happens. Oops. Do we know these two? I don't think I need these 1, 6s penciled. Is there anything that this helps with at the moment? Blue is here. If this was 1, it would be orange. Let's see. So let's think about this a little bit further. Again, if this was 6, then this couldn't be 1. So 6 forces this to be 2. 1 forces it to be 6. I mean, all that tells us is that 6 is one of these two, which we already knew. Is it this guy? If this is 2, that's 1. I mean, that's just a pair. I mean, again, this doesn't care whether this is 1 or not. So I don't see how this 1 here is doing anything beyond the marking because it's already given us. So I don't think this coloring has helped me. So let's get rid of that as well. So there must be something that I'm missing about. It's got to be this diagonal, right? Is there a problem with... Oh, yeah, okay. Yes. There is a problem with this being 6 and this being 1, which is that this would have no value. Basically, this, if this is 6, that's 1, and now this has no value. So it cannot be 6. It must be a 1, the boring one. All right, so that's 2 and that's 6. That's 2 and that's 1. I was really hoping it would end up being a 6, but whatever. That's 1, that's 1, that's 6, that's 2, that's 1, 6, and 2. All right. Cool puzzle, Strosahl. I enjoyed that. Had some neat logic, and at first I was like, how are we going to even get started on this? But it actually flowed really nicely. Cool. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.